saints in lockstep.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard. We shall analyze the following situation. A barrel has been hung from a cable, and there's also a horizontal beam supporting the two. And we need to find tension force in the cable that is along the direction of the cable, and then whatever support force is provided by the pivot point here, essentially the point where the beam attaches itself to the wall. So it's a rigid body, so we don't really know its direction, so best we can do is to divide it into two components. So let's call this ny, and the horizontal component just nx. And then also, from this geometry we can calculate these angles, and here we have angle alpha. Alpha is 53.1 degrees. And same thing with tension force. We can divide it into two components. So if you think about the situation, so the mass of the barrel is acting down, so the initial guess would be that maybe the tension force in the y direction is up. It doesn't matter if we guess it wrong, it just shows up on the sign of the force or that component when analyzed later on. And let's put the horizontal component this way. It's a guess based on the fact that nx is that way, so tx is probably going to be that way. Or if our guess from the nx was wrong, then the tx would in fact end up being the other way. But again, the initial guess doesn't matter with the direction. And here we have ty. And if we continue this, the direction of the cable, somewhat like this, we see that the same angle alpha is here, like this. And now the conditions of a static equilibrium. The sum of forces in both directions must equal to 0. So what do we have in x direction? We have nx. So let's make this clear. Positive directions are as follows: to the right, to the up, and positive torque clockwise. So with the forces in the x direction, we have nx minus tx, and that must be 0. And in the y direction, we are in fact missing one of the forces. So of course there's the weight of the barrel, called W, pointing down. So in the y direction we have positive, we have ny, we have ty, and W is negative. Then the sum of torques about some point. We'll choose it about this pivot point to get rid of ny and nx, or get rid of their contributions to torque. So in that case, in positive direction we have the weight multiplied by, let's call this delta x. That's the lever arm for the weight. And then another torque is here from tx. Let's call this delta y. So that's in the counterclockwise direction, so that must be negative. So minus tx times delta y, and that's also 0. So what do we have? We have how many unknowns? Nx, tx, ny, and ty. So we have 4 unknowns and only 3 equations. Luckily, we know the direction of the tangential or the tension force, because in a rope or a cable it's along the direction of the rope. So from this geometrical identity we can say that the tangent alpha is tx divided by ty, because we can always draw the tx here as well. So tangent alpha tx divided by ty. And here we have 4 equations, 4 unknowns, and we can solve them. So where do we start? So does any of these equations have only one unknown? So that has 2, that has 2. This one has only tx, so we can in fact solve tx from here. So tx is weight times delta x divided by delta y, and that is 300 newtons times 4 meters divided by delta y, 3 meters, so that's 400 newtons. And then we can take that one and put it here. So nx is same as tx, so that's also 300 newtons. And continuing with the tx, we can in fact solve for ty from here. So ty is tx divided by tangent alpha. Tx is 400 and alpha is 53.1 degrees. And that gives, in fact, nicely 300 newtons. And what do we have left? Nx, tx, ty. We only have ny, so we resort to the second equation. So ny is weight minus ty, and weight is 300 newtons, and so was ty from here. So we in fact see that the ny component is 0, so the force provided by the beam or the wall is horizontal. Only thing that is left, we need to find the magnitude of t, so that's going to be square root of tx squared plus ty squared, tx 300 newtons squared plus ty oh, there's a mistake, so tx was 400, so that's going to be 400 like this, and ty like I had here, 400, and ty then turned out to be 300. Good. That's 3, 4, 5 is a perfect square in that sense, so we get 500 newtons for the magnitude of the tension force. And all these magnitudes that we had, they turned out to be positive, so ty, tx, and x. So they are indeed in these directions that we originally guessed.
Oh,